Okay guys, this video talks about simplifying radicals. It's on page 12 of your summer packet. This is mainly a geometry skill, and to understand this you need to understand the perfect squares. So what I mean by perfect squares is we'll start there. So what I'm going to do is start on this page and we're going to start listing perfect squares. When I say perfect squares, I mean numbers that are whole numbers, like 1, 2, 3, 4, 5, that we multiply by themselves to get new numbers. Sorry, I keep messing up here. But basically, for example, we're just going to start listing them. If I take 1 and square it, I get 1. So 1 is a perfect square. If I take 2 and square it, that gives me 4, which is a perfect square. If I take 3 and square it, I get 9, which is a perfect square. If I take 4 and square it, I get 16. 5 squared is 25. 6 squared is 36. 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared 100, sorry, not 181, 81. We can keep going here if we want to. I think it's really an important skill to know the first 20 perfect squares by heart. So if we go really quickly, we'll do a couple more. If we do 11 squared, we get 121. We do 12 squared, we get 144. We do 13 squared, we get 169, and so on, right? Dot, dot, dot. The idea is the easier we can recognize these numbers, the better we can solve the problems on page 12, and we can also recognize some other important things that we will see this year that have to do with perfect squares. So if I go back and I apply this to number 1, number 1 is an example that was already done for you, so I'm going to actually start with number 2. The idea is that when I have a radical is just a square root symbol of any type. When I have something like that and I have a number underneath that I want to simplify, the way that I do it is I look and see whether that number is divisible by any of the perfect squares on this list over here. So when I look at 90, for example, I can say, well, yeah, 9 goes into 90. So what I can do here is I can make this square root simpler by rewriting it. So instead of writing the square root of 90, I'm allowed to write it as the square root of 9 times the square root of 10. That's how square roots work. I can multiply 10 times 9 under the square root and get the square root of 90. But now by doing this, I've done something actually pretty clever. I've made this problem simpler because I can take the square root of 9, and that actually becomes a 3. I can't take the square root of 10 and get a whole number. I can take it and get a decimal, but I'm not interested in doing that. And also I can't break it down any further, so I just leave it, and this becomes 3 times the square root of 10. So instead of being the square root of 90, which is a kind of big number, it's a lot easier to write this problem as 3 times the square root of 10 for multiple reasons, mainly because it's simpler and looks easier, but also because if I was doing a more complicated problem, it's possible that this 3 could cancel out with something, which would make my problem even simpler. So you can see how this works. We're going to do the same thing a little bit faster here with number 3. Number 3 is 72. We're looking for the biggest perfect square, so I go over to my list and I say, well, I think 36 goes into 72, so I'm going to use that. So I'm going to rewrite this as the square root of 36 times the square root of 2. I take the square root of 36 and get 6, keep the square root of 2, problem is solved. Number 4, square root of 200, we're going to rewrite that. The square root of 100 times square root of 2. Square root of 100 is 10, keep the square root of 2. So you'll see that without knowing what the perfect squares are, this can be a lot harder. But when you practice and study the list that we just created over here on this page, then these problems become a lot simpler because you'll know what the perfect squares are, and then you can reduce these problems. If we look at number 5, we have the square root of 275. We can actually break this down to 25 and 11. When I take the square root of 25, I get 5, and we keep the square root of 11. Now, one other thing that we could do here is we can make a tree. So I'll show you an example for when I get to number 8 about how to do the tree method, and if you don't like this method. But let's just work through 6 and 7 using this method, and then I'll show you the new method for number 8. You notice that number 6, 7, and 8 are a little bit different. Number 6 already has a number on the outside in addition to the square root inside. So we're going to keep the number on the outside and just remember that it means multiplication. So this is 4 times. Now we're going to break down the square root of 24 into the square root of 4 because that's a perfect square times the square root of 6. When I do that, sorry, this 4 looks like 9, so I'm going to change that. So when I do this problem again, I get the square root of 4 times the square root of 6. Now we know that the square root of 4 is 2, so this is 4 times 2 times the square root of 6. 4 times 2 ends up being 8, so I have 8 times the square root of 6, and that's my final answer. Notice that you don't need both of these numbers to be perfect squares, just one of the two for this to work. Okay, when I get to number 7, same thing, I'm going to look at the square root of 18. I'm going to break that down into, we keep the 2 on the outside, and then we break that down into the square root of 9 times the square root of 2. We know the square root of 9 ends up being 3, so I have 2 times 3 times the square root of 2. When I multiply that, I get 6 times the square root of 2, which is my final answer. When I get to number 8, we know that the square root of 90 breaks down to 3 times the square root of 10, so we're going to keep the 5, and then we're just going to write our answer from earlier in our work, and then we're going to multiply the 5 and the 3, get 15. We have 15 times the square root of 10.